Chapter 5, 5.4, acid reactions in daily life. These questions are not very important, but we do see an MCQ here or there from this part. This is mostly knowledge-based part. This is mostly memorization. Understanding has very little to do with a couple of these everyday life examples. Starting off, we know that the dilute hydrochloric acid in our stomach helps us to digest the food, and we are talking about HCl. This has low pH. The pH is usually around 1 to 3 when we are talking about the stomach or gastric juices. However, sometimes our body secretes excess acid that causes indigestion. It can be painful because acid can act on the walls of the stomach and eventually give rise to ulcer. Ulcer is actually a disease we study in biology, in which we have holes in the wall of stomach, right? So holes in the wall of stomach because stomach has excess acid and you didn't get enough food, it's actually a pretty big problem. It's very painful disease, and in this disease, eventually you lose your appetite as well as your capability to digest food properly. So actually the whole energy in the body comes from the food, and if not, you're not able to digest food, or if you don't have any appetite for it, it becomes a problem. So try not staying hungry for a longer duration of time, specifically in the first 20 years of your life. That is when the body acids are very strong, and staying hungry for a longer time can cause problems like this. Now, to ease them up, we have antacid treatment. What's an antacid? Antacid is a compound which has no toxic effects on the body, and it is just used to neutralize the effect of acid indigestion. Now, in order to get an antacid, I'm going to go back to the big, huge table we had where we had the acidic and the alkaline values for things that we commonly see in our daily life. Now, take a look. We need something to counter effect the effects from the acid, the problems that are caused by excessive acid. Now, anything above neutral range, something above than 7 or less than 14 would work for us. Anything from 11 to 14 would not be good for us, as it would be too corrosive, and even it can corrode or cause problems to our lips, tongue, and the whole mouth. So we can use anything in between higher than 7 and less than 11. You'll see many things over here. Of course, we can't take blood as an aid. Baking soda solution may help. We can't ingest toothpaste. That's not an option. Borax solution is not an option. And then there comes milk of magnesia. Milk of magnesia is commonly taken as the best treatment in this case. However, if that's not available, a little bit of baking soda solution can also help you with excess acid problems. Remember, if we have excess acid problems in our body, we can treat them with an alkali. If we have excessive alkali problems, our body is not producing enough acids, we can always have some acidic stuff from here all the way to here that can help us with those effects. So take a look, we need something lower than 7. And of course, we can't directly use stuff from 0 to 3. Lemon juices can be used after they're diluted, or vinegar can be used after they're diluted. But if we use them directly, they actually can hurt our throat, and we can have throat issues and throat infections afterward. So anything in between 3 to 7 is good enough if your body is producing less acid than what's required. So tomatoes are good, black coffee is good, wine might be good too, but it's not actually prohibited for Muslims, so I'm not going to take it as an option. Acid rain is not an option. Urine is not an option, of course. Rainwater is not an option. Milk can be a good option as well. So if your body is producing less acids, these things can help. Now, these two have a pretty good range of values. They're not bad for us. They're not bad for the mouth or the stomach, and they have lower values to get us through. So this table is pretty good.
What about lemon juice, sir?
Lemon juice, if taken directly without dilution, can cause a throat problem. Then and there, you will have problems on throat. It can cause infection with the throat. So we need to dilute lemon juice. That's why we have lemonades. lemonades are actually the diluted forms of lemon juice. So they can work well, yeah. Or if you dilute vinegar and then take it, it can also work well too. That's why I said these two are good, but after they are diluted. If they're not diluted and you try drinking vinegar, you will have a weird sound. It will directly attract your sound box in your throat. It would give you dryness and rashes on your throat, which is going to take 2 to 3 days to heal. So direct lemon juice consumption or direct vinegar consumption is not good for our throat, either for our mouth. Right? So moving on, let's get back to the topic where we were. So as I was talking about the excess of acid, and as I told you that milk of magnesia can be a very good option. Actually, milk of magnesia is an insoluble material and it is commonly used to counteract the effects of acid. Now, milk of magnesia contains insoluble magnesium hydroxide, the formula of which is MgOH twice. I usually ask my students to keep writing the formulas of any acids or antacids or alkalis that we are going to go through this topic. So whenever they ask about the question about these in MCQs and they don't use the names, you can always connect the names to the formula. Now, there are effervescent fizzy antacid tablets such as Alkalis, or there are many other names in the market. Different companies have different marketing names. They contain soluble material. They contain sodium hydrogen carbonate. Now, this is what we were previously calling baking soda. And the formula of it is NaHCO3. Now, you remember on that list, we had 1, milk of magnesia, and 2, we have baking soda. So both of them have been given over here as a good solution. Apart from that, these tablets also contain citric acid as solid acids. On adding water, acid and some of the hydrogen carbonate react. They produce carbon dioxide gas, which actually fizz in the glass while mixing. So that's what we see along with these tablets. So when the mixture is drunk, it is going to counteract the effects of acid with the help of the baking soda, and it is also going to give help to us by giving us some vitamin C, ascorbic acid, or citric acid. Ascorbic or citric acids are actually good for the body, so taking them in small amounts along with these tablets is a pretty good idea to start with. Now, remember importance of adding water to start the action of the acids. Tablets do not react in the packet until unless we add water. There won't be any effervescence, there won't be any reaction. Soluble aspirin tablets work in the same way. Aspirin are usually marketed by the name of aspirin, by the name of dispirin, by the name of, there are other market names as well, right? So moving on, descaling kettles. Now, the kettles that we use commonly come up with these white scales all over the kettle. This was supposed to be of silver gray appearance, but it's almost white now. We call them scales. Scales actually come because there are carbonates of lime, calcium, and magnesium, which whenever we are boiling water in the hot water areas, calcium carbonate, the formula of which is CaCO3, along with magnesium carbonate, can cause these white scales. They stick to the substance, whichever substance or kettle we are using for the purpose of boiling water. Now, sometimes these scales can be removed with some knives and some sharp stuff, but that's a tedious work to do. We always prefer that they are removed by treatment with an acid strong enough to react with calcium carbonate, but not strong enough to damage the metal. So what we do is that vinegar can be used to descale kettles at home, and commercial descalers use methanoic acid. So I tend to ask my students that along in this whole paragraph, you only need these 3 lines to be memorized. Remember, the formula of vinegar is CH3COOH. It is ethanoic acid by another name. And this methanoic acid has the formula of HCOOH. Both are acids, they just have slightly different formulae. all right? So what we are saying over here is that vinegar is used domestically. That's not written domestically over here, but you may add it to this sentence. And methanoic acid is the one that is used commercially. I've seen a couple of past paper MCQs from these three lines. So what do? Pour in some vinegar, wait for it, let the vinegar sit and react. This might take a couple of hours. Wash it, rinse it, you're good to go. The kettle will be good as new. Moving on, soil pH and plant growth. Now, before I start with this topic, let's take a look at this table, 5.6. You would see many different vegetables and their different preferred pH ranges. You would see some are going around the neutral pH 7. Some of them are slightly acidic. Take a look, it's acidic. This one's acidic, this one's acidic. This one's in between acidic to neutral or slightly alkaline. This one is very slightly acidic. This is mostly alkaline or neutral. So we have different vegetables ranging with different pH ranges that they can grow onto. And in between these big pH ranges, they'll grow to their best size. Potatoes, chicory, parsley, carrots, sweet potatoes, cauliflower, the list goes on. So we do understand some of the vegetables require a little bit acidic conditions, some of them require neutral ones, and some of them require slightly alkaline conditions. So
do we have to memorize these pH values, or
no, you're not supposed to memorize them. This is just for the information.
Okay.
Okay. So coming to this topic, soil pH in plant growth is very important. If soil pH is good, the plant growth would be good, and vice versa. Soil pH good means the soil pH doesn't have to be high or low. It has to stay in the range, whatever the plant requires. Now, moving on, in some areas, the soil is naturally acidic. In some areas, the soil is naturally alkaline. In some areas, soil becomes acidic due to the rainfall. So there are different conditions and different plants prefer different pH conditions. Farmers and gardeners need to test the soil pH and they take it to the suitability of particular plants. First paragraph is nothing that you require for exams. You specifically require the second paragraph for exams. Let's go through this paragraph. This is very important and has been discussed in both paper 2 and 4 before. If the soil is too acidic, this can happen because of the continuous use of fertilizer. This may happen naturally. This may happen due to excessive rainfall. So in some areas, the rainfall is acidic. Acid rain causes acidity in the soil. So we treat it by liming. What does the word liming means? Lime is actually calcium oxide. It's a loose term. We are actually using calcium oxide, but in some parts of the world, they may use calcium hydroxide, which is CaOH twice, or they may use powdered chalk or limestone calcium carbonate, which is CaCO3. Now, all of these compounds wind up by giving alkalinity to the soil. This alkalinity can counteract the acids effects, and these compounds have neutralizing the acidity of the soil. Now, let's say a farmer has been using the liming process. He's adding lime to the soil. Unfortunately, he miscalculates it. He adds more lime to the soil than required. Of course, he's not going to turn the acidic soil into neutral one. He is actually going to turn it alkaline. Now, if the soil becomes too alkaline, what do? We never add acid to the soil. Remember it. What we do is that we do it slightly technically and slightly in an indirect way. We dig in some peat. Peat is the soft form of coal, softest form of coal actually. We may put in some decaying organic matter, compost, manure, fallen leaves, anything like that would help. Organic matter means dead parts of plant, manure, compost. And what do these do? Actually, they don't do anything on their own. The word decaying tells us that microorganisms would work on them. Microorganisms are going to take them as food. They're going to take this soft form of coal or organic decaying matter or fallen leaves as food. When they're going to eat their food, they're going to release waste. The waste out of microorganisms is acidic. That acid is going to counterfeit the alkaline conditions. There you go. You have already neutralized the alkaline conditions. So it's an indirect way. It takes a couple of days for the fallen leaves or the coal or manure or compost to be converted into acid by the decaying action of microorganisms. But yeah, we can work out our way out and utilize the alkaline effects. So this last paragraph is important. Moving on. Some flowering plants can contain their built-in indicator. There are many flowering plants around the world which come in multiple colors. We talk about tulips, we talk about chrysanthemums, we talk about roses, the list goes on. They have their own pH indicators. That's the best part. Rose comes in so many different colors because they have their own pH indicators. The soil is slightly alkaline, they'll show a different color. The soil is neutral, they'll have a different color. The soil is slightly acidic, they have a different color. If the soil is more than slightly acidic or more than slightly alkaline, they'll show different colors. You would see roses in 10 or 15 different colors. So would you with tulips, a little less colors in case of tulips, not like roses, but they show many colors. Chrysanthemums do the same. And there are many other plants. This one is hydrangea. This one also shows different colors. The reds depict acidic condition, the blues depict slightly alkaline conditions, the purples depict almost around neutral conditions. Nature is working its way with different colors because of different pH conditions, and we take it as a part of their beauty, which it is definitely. Which brings us to our last point for this topic, effluent and wastewater treatment. Effluent is anything that can flow out of the industry as a waste. Now, if we're talking about something that can flow, of course, effluent would be in either liquid form or gaseous form. Now, the liquid waste from factories is often very acidic. If such waste gets into the river, the acid will kill the fish and other river life. Slake lime, which is CaOH twice, is often added to the waste to neutralize it. Slake lime is similarly used to treat streams, rivers, and lakes affected by rainwater, acid rain, or any kind of acidic waste. In order to reduce the entire emissions, what we do is that this mostly happens because of sulfur dioxide. Remember, we have previously discussed that sulfur dioxide is harmful because it can add with water and it may turn into sulfurous acid. Now, sulfurous acid is pretty acidic, or if sulfur dioxide somehow gets oxidized more, it is converted into sulfur trioxide, which can be added to water to give us sulfuric acid. Now, sulfuric acid is even more harmful than sulfurous acid. So both the acids are pretty harmful. So we try to stay away from the oxides of sulfur, which are basically causing this problem. So many modern factories and power stations now spray acid-based gases with jets of slake lime in flue gas desulfurizers or scrubbers. What is a scrubber? A scrubber is like a collection of showers. The same showers we have in our bathrooms that would we bath with. The shower is usually a structure which can shower water. And if we have a collection of showers in a big pipe in which we are passing through the acidic water or acidic gases, the acidic gases will turn into acids right here in the shower instead of what they do in the atmosphere. So what we do is that we use these showers, we call the scrubber, to convert SO2 and SO3-like gases into sulfuric and sulfurous acids. Now what happens is that all acidic gases are converted into acidic solutions, right? And what we do is that we add to these acidic solutions slake lime. What happens? They react they get neutralized, and we have the neutral solutions that we can throw out as waste. And those neutral solutions are not going to kill fish. Problem solved. Although those neutral solutions may add more and more lime to the water, which is giving us hard water nowadays, which is the after effect of it, but it's way better than producing acid rain, because the problems associated with acid rain are way bigger than what we have with these liming problems. All right. So liming comes with a couple of disadvantages, but it's way better than to deal with the acid rain or the acidic gases as a whole. This concludes our topic for everyday uses, but it only concludes the portion over here. There is one portion which is also included in this topic, was a part when in the third edition of the book, but is not part of this topic exactly here on these pages. Instead, what they have done is that they have brought this specific part over here, nature's defenses or sting alone. Now they're going to talk about the stings from different insects or bees or stuff. We do understand that the acids that we commonly talk about, like we have talked about methanoic acid, which is also written over here, this one. Methanoic acid was used known as formic acid. The word formica comes from ants, which it literally means ants. The acid was first originally made by the distillation of red ants for their bodies. The acid is part of their defense mechanism. When an ant stings you, it injects the methanoic acid under your skin. That's why you have that scratchy feeling when an ant stings you. You can neutralize the skin by rubbing on some baking soda from the kitchen. You might use calamine lotion, which contains zinc carbonate. Sodium hydrogen carbonate is NaHCO3, as I've explained before, and zinc carbonate is ZnCO3 as per its formula. This is about ants. Bee stings also contain methanoic acid, although they also contain other highly acidic chemicals, and we can treat them with baking soda. If you don't have baking soda, remember, we have discussed about it. Toothpaste is also an alternative, or milk of magnesia is also an alternative. Remember, anything slightly alkaline can always help us neutralize the effect of an acid. In contrast, a wasp sting is alkaline and can be neutralized using lemon juice. If lemon juice is not available, which contains citric acid, you can always go with apple juice. You can go with tomato juices, or simply apply the tomato puree, or you can use maybe use wine on the sting area. You may also use vinegar, right? So what happens is that they will counter effect the alkaline effects, and they would neutralize the sting for you. Bee and wasp stings can be dangerous for people who develop an allergic reactions to the proteins in the venom, right? So we can work our way with different chemicals that are commonly available at home to counter effects these stings. This also has been a part of the same topic, but it's just present on a different page, right? So let's get back to our topic. We're done with 5.4. Let's move on to 5.5. 5.5, alkalis and bases. We have already defined bases. We're just going to differentiate between alkalis and bases. Before we do that, we have been continuously using the word neutralization. What is neutralization? Neutralization is reaction of acid to the base to produce both neutral substances, salt and water. That's how salt is formed. Now, what is a base? A base is actually a bigger, broader term. As you can see, we are using Venn diagram to explain what bases or alkalis are. Take a look. Bases are given in the larger circle. It can be anything that can neutralize an acid. Some of them are insoluble in water, or some of them are soluble in water. The ones which are soluble are given in a smaller circle. We call them alkalis. They are soluble. There may be other which are completely insoluble. For example, copper oxide is insoluble in water. And there are other which we are going to see in the upcoming table. So simply speaking, we right now talk about base as anything that can neutralize an acid, and most probably it's going to be insoluble in water. And we are now going to refer to alkalis as bases. It's just that they are going to be the soluble ones and they're going to be soluble in water. So how can we differentiate between them? There are some common alkalis. They're also given in the next table. We'll see the table, but first the definitions. Bases can neutralize acids to give salt and water. Bases are usually oxides and hydroxides of metals. Bases are mainly insoluble in water. Alkalis, however, are bases that dissolve in water. They feel soapy to the skin. By that, they mean slippery. Soapy means slippery. If you can't think of the word, you can use the word slippery and get the marks. It can turn red litmus paper blue. It gives the solutions of pH greater than 7, and the solutions also contain excess of OH negative ions. Now, antacids are compounds that are used to neutralize acid indigestion. And among from bases or alkalis, antacids include magnesium oxide and magnesium hydroxide. This one is MgO. This one is MgOH twice. Sodium carbonate, which is Na2CO3. Sodium hydrogen carbonate, which is NaHCO3. Calcium carbonate, which is CaCO3. Or magnesium carbonate, which is MgCO3. Right? So these are all that are used for antacids. Remember, antacids are specific compounds that can neutralize acid indigestion, and they're not bad for human body. So all the formula that are written over here can easily be ingested by a human, and they won't give any problems to humans. That's why we use baking soda so easy. We use sodium carbonate so easily. We use milk of magnesia so easily. Right? So moving on, we have a big, huge table differentiating between alkalis and bases and their common usages. So we're talking about sodium hydroxide, which is NaOH. It's a strong one. It's used in oven cleaners or degreasing agents. It's also used in making soap and paper or other industrial usages. Then we have potassium hydroxide, the common name of which is caustic potash. Remember, you're supposed to memorize this entire table, every single word of it. It is used to making in soft soap and biodiesel. It's also used actually to make shaving cream and foams. Then the next one is calcium hydroxide. We also call it lime water. It's strong. It is used to neutralize soil acidity, acidic gases produced by power stations.
So like it's written where they're found and used. So do I have to memorize like every single use or every single involvement, or can I just memorize one or two, or do I have to memorize all of them?
If you have to prefer upon memorizing one or two, try going with the first one in every case. For example, oven cleaners in this one, soaps in this one, neutralize soil acidity in this one, so on and so forth, right? If you have to choose. Otherwise, I ask my students to memorize all of them, because Cambridge does the same thing with the students, that 1 year, if they're talking about this use in their MCQs or theory papers, next year they're going to talk about this one. So if you're just going with the first one, you might get confused in MCQs, not in theory papers. Of course, in theory papers, it's an open-ended question. You're supposed to write a couple of uses. You just write the first two of these and you get your marks. Good, fine, understandable. What about MCQs? That's why topicals are so important. They give you an idea which topic's important, which topic's less important, and with how much frequency do they go with the topic. Is the topic repeated in every year or every season, or is the topic not repeated so frequently? We're talking about acids and alkalis. They're repeated in pretty much a number of times. Ammonia solution, ammonium hydroxide, both the names are acceptable or the formulas. I haven't seen a single paper without this one. This one is very important. It's weak, however, it's used as cleaning fluids in home. The bases are simply calcium oxide and magnesium oxide, and we have already understood their uses. However, calcium oxide has way more uses, which we are going to discuss in chapter number 9, which are only given over here as starting pieces of detail. This also completes 5.5 for us. And